Hello and good evening, CTS267, Section 840 students for the Spring 2017 semester at Anne Arundel Community College. This is the CCNP TSHOOT course, and this evening's video tutorial and solution set is going to be for challenge activity number 18. So we're down to the last 3 challenge activities. And this is the Radulko Limited, the second set of tickets we're going to be looking at for Radulko Limited here. And so let's go ahead and dig in. Again, a much more complex setup than some of the previous activities. And it looks like for this we're going to be looking at an email here. So Marjorie has contacted us and she sent us an email. So switch 2 was stolen. So I had to replace it with an old switch I got from our storage unit. I copy and pasted the configuration from the backup. However, PC1 and PC2 do not have connectivity to the internet. Alright, so switch 2 is this switch here, and this was the switch that was stolen. My guess is I think these are all layer 2, and we'll check this out. I think these are layer 2 switches. They're probably doing HSRP here. So it could be a router on the stick issue with the HQ2 router and switch 2. I mean, it could be a whole host of things. It could be she forgot some of the configuration. So, and again, the key here is when you read this, I copy and pasted the configuration from the backup. Now, typically the VLAN information is not... Well, if you've got the switch port access commands, it should create the VLANs for you. So we'll jump on there and take a look. So please fix this. I've also just configured the network to run IPv6 as well. Everything seems to be fine, except I can't ping the IPv6 internet from the branch router, which is over here, and multi-protocol BGP. And this was a question that had come up. Leonard and Evan had asked a question about this, and so this is the one we're going to be getting to take a look here. It seems to be working through ISP1 while the session with ISP2 is not being fully established. Can you take a look? And always nice to see that we can look at the customer documentation, but it might not be accurate or complete. Could send us on a wild goose chase. And let me write these IPs down: 209.165.201.133 for IPv4, and you'll only be able to ping this internet address if the source is a private IP address, for example PC1. Okay, if you need to test IP, so 2001 db8 0d:100. All right, so let's dive in here first, and let's take a look. Well, first let's do this. Let's confirm the issue here. So the issue is that we can't get to the internet, so let's try to ping this 209.165.201.133 address. So we've seen this before. So if I was to say show IP interface brief, what we should see, and again we saw this with a number of the DHCP scenarios, is that it's not getting a DHCP address. And that is exactly what's going on. If we looked at the interface, show run interface Ethernet 00, we would see that we've got the IP, so IP address DHCP. They've got the IPv6 address autoconfig and the IPv6 enable commands here. So if we were to say show IPv6 interface brief, let's try that again. You can see that we've got the link local address, which was an EUI 64 generated local address using the MAC on the interface. Okay, so the interface is up, but there is no DHCP connectivity. So the next thing to do is we're going to take the bottom-up approach here. Let's check PC2 as well and include PC2 show IP interface brief. And yeah, no IP address. So if I was to try to ping 209.165.201.133, exactly, we get that same error. So switch 3 is our first contact point here. So let's take a look at switch 3. And let's get our password in here. And let's say show IP interface brief. It looks like quite a few interfaces. VLAN 1 and VLAN 100 are down. So let's see. It could be that maybe the VLAN assignments, although that should be show VLAN brief. And this is the first thing that should pop up here. So we went bottom up, right? So we took a look at the interface configuration on the PCs, and now we're taking a look at the VLAN configuration, and we notice that VLAN 100 is down, down. And the reason it's down, down is there's not an interface that is in VLAN 100. In fact, VLAN 334487, let me take a look at the job aids here, because that doesn't sound, if it's using the same topology, which it is, then my guess should be that we are dealing with, yeah, headquarters addressing. So the servers, and again, we're in the HQ side, right? So here, this is the HQ side with, and that's interesting. You'll notice it shows two links here between switch 1 and switch 2, but the actual topology diagram shows a single link between switch 1 and switch 2. So yes, the job aids can definitely be misleading, and so that looks like it could be an issue, but let's continue to look here. Let's get back down to here. So the server VLAN should be VLAN 2, and there are no servers. We just have PCs. The HSRP is running, right? And it's 10.0.2.1, and they're all /24s. And what's interesting here is that the documentation doesn't say what VLAN should be used for the 10.0.100. So when we look at this, you can see right here. So clearly the servers, of which there aren't any here on switch 3, or in the HQ side, but there are PCs. So PC 1, or A, I believe it is, in PCB, those should be in VLAN 10. And then here they show, so they're basically, you know, they're basing it off the third octet. The VLAN number matches the third octet, but there's nothing here that says VLAN 100. So the management, and that's that VLAN that you saw here on switch 3, the management VLAN, that has got to be why that's down. And I'll bet you switch 1 and switch 2. So here's what we can do. We can do a quick compare and contrast, because remember, switch 1 and switch 2 was ripped off. So we can look at switch 1, and let's leave that up. We'll look at switch 1 to determine, do a little compare and contrast here. So let's get switch 1 up, and let's go from user exec to privilege exec. We'll get our password entered in here, and show VLAN brief. And so we've got the same VLANs here, and let me see, show IP interface brief. So is there a VLAN 100 here? And there is, and it's down, down. And so what about switch 2? Get the password in, show IP interface brief. So it looks like the documentation could be, yeah. So switch 2 is 10.0.112. Switch 3 is 10.0.113, and switch 11 is 10.0.111. Now what's interesting is that those VLANs are gone. Now back to the scenario, and this will be interesting if this is... So I had to replace it with an old switch I got from our storage unit, and I copy it. So it couldn't have been that it overwrote. I guess it's a possibility that the switch that she grabbed, and I've actually had a coworker experience this, where he grabbed a switch from our storage area, put it onto the network, not realizing that the switch had been in service for 5, 6, 7 years and was a VTP server, and the introduction of that switch into the environment, it overwrote the segment, show VTP status, the segment that he plugged it in on. Local updater ID disabled. Because I don't see VLAN 10 anywhere, and I don't see VLAN 100 anywhere. And that has got to be, so let's double check. Let's look at the HQ1 and HQ2 routers. I want to confirm that the show IP interface brief that we've got, yeah, VLAN 2, VLAN 10, VLAN 100, and what I can assume is going to be VLAN 3. If I were to say show run, I want to see the interfaces for the NCAP. Because again, remember, the NCAP.1Q doesn't have to match the sub-interface number. But this definitively tells me that we're dealing with, and it looks like we've got EIGRP issues here too, we're dealing with VLANs that are missing. Yeah, NCAP.1Q 100, NCAP.1Q, and this interface is just nothing. Okay, so it has to be that something is wrong with the way the VLANs are set up. And so typically, and I'm not sure if this is what they're looking for. So there's a couple things we could do to address this. So we're going to wipe these VLANs out that aren't needed. This would be a VTP server, that would be a VTP server, and that is typically the client, right? So we'd have the two VTP servers here, and the VTP client would be here. So let's go ahead and approach this from the VTP angle, and let's get this solution knocked out here. So let's get on to switch 1, and here's what I'm going to do. Let's go into global config, and we're going to say VTP mode server, VTP version, we'll change it to 2. We're going to put a password, VTP password, we'll just say Cisco. And then let's get into, let's say do show VLAN brief, and we're going to say VLAN, what was it, 2, and we'll name that servers. We'll say VLAN 10, we'll name, okay, VLAN 10. So it looks like it's going to make us wait here while it applies these changes. May take a few minutes. All right, well, we don't have a few minutes, so let's go down to, we'll deal with switch 3 here. We'll turn this into the global config, and we're going to say VTP mode. And so to clear it out, we would say VTP mode transparent, right? And then do show VLAN brief. So that's what we see. But now what we're going to say is we're going to say VTP version 2, already version 2. Okay, good. VTP mode client. VTP password is going to be Cisco. All right. And let's go back to, not switch 2, sorry, switch 3, no, switch 1. And is this done yet? Well, maybe I have to exit out here. Let's get back in the global config and say VLAN 10. All right, that worked. Name PCs, and then VLAN 100. And it looks like it's going to make me exit out each time here. So we'll say end global config VLAN 100. So those were the 3 VLANs we had sub-interfaces for. Yeah, name is, what was that? Management? Management. All right, so there we go. And now what we're going to do is we're going to say, do show VLAN brief, and then I'll exit out. We'll get back into global config. So no VLAN 33. Oh, it looks like it's going to make us wait here, and this is actually a little disappointing. All right, so as you can see, VLAN 100 is up, and what do we got going on over here? So switch 2 is going to be, so 1 and 2 are servers. So let's get into global config, and let's say no VLAN 33, and it's applying changes as well. So let's do this. Let's say VTP mode transparent, and then VTP version 2, okay, VTP mode server, VTP password is going to be Cisco. Do show VLAN brief. All right, so we've gotten rid of no VLAN 44. So it's still applying. Yeah, this is kind of frustrating with the application of these changes. Do show VLAN brief. All right, so this picked that up. So if we go to switch 1, maybe we can get a change here. No VLAN 44. Boy, oh boy. get back into global config. No VLAN 44. Wow. All right, so this is unfortunate. Do show VLAN brief. Okay, well, it got rid of it. No VLAN 87, which is obviously also do show VLAN. Maybe it's getting rid of them, and I'm just not paying attention. There we no VLAN 153. Okay, and then do show VLAN brief. All right, so that looks better. VLAN 10, VLAN 2, and VLAN 100. If we say do show VLAN brief here, there we go. 2, 10, 100. We go to switch 2. Do show VLAN brief. All right, so we are good to go across the board. Do show VTP status. All right, let's take a look. What was it? Switch 3 should show do show VTP status. Okay, so now do show IP interface brief. We should see that VLAN 100 is up. So if I ping 10.0.100.11, it should work. 100.12, maybe it ARPs out, but we should be able to reach switch 2. Excellent. All right, so we've restored connectivity. We've got the VLAN sorted out. But when you look at when we look at switch 3 on that do show VLAN brief, and that's convenient. The ports must have already been do show run. Yeah, the ports must have already been. Yeah, there. Okay, so the ports were already configured. So we should. Okay, and then we go. There we go. Our trunk port is allowing the right VLANs. So let's go back to the PC. Let's see. Did we end up picking up? And this was pretty involved. Yeah. All right. We've got our IP address. Show IP interface brief. I've got to say that is probably one of the more involved tickets we've worked on with not a lot of information. So let's ping out to 209.165.201.133. And again, great. Okay, so we've got connectivity. Again, what also could have been done is you could have just dumped them all into transparent mode, but then you would have to go and make the changes for all 3 switches. You'd have to do it on all 3 switches if you moved them into transparent mode. So I just went ahead and we set the 2 sort of quote-unquote distribution switches, even though they're not multi-layer switches. We went ahead and set those up as the VTP servers and made switch 3 our VTP client. And I guess we should check. Let's make sure for completeness here. Let's get back into the command line and ping 209.165. And I'm glad I wrote this IP down. All right, good. So we're sorted out there. So that was the first issue. The scenario's a little baffling here. So switch 2 was stolen. I have no idea what happened. I need the network to work before Monday. All right, so that's solved. All right, I have also just configured the network to run IPv6 as well, because of course when the network is down, that's typically when you go in and start implementing all kinds of changes. And that's sarcasm there. So not typically the approach you would take when your network is down would be to go in and set everything up for IPv6. I cannot ping the IPv6 internet from the branch router and multi-protocol BGP. And so again, that was the question that Evan and Leonard had. While the session with ISP2 is not being fully established, can you please take a look? Only seems to be working through ISP1. Okay. And so the question was, I think you guys were talking about IPv4. Was it V4 over V6? Is it V6 over V6? And so we'll save that one for last. Let's tackle this branch router issue first. And I'm not sure if that was, yeah, the branch comes directly into HQ1. And there we go. So now we're getting this retry limit exceeded, and then the adjacency comes up, and then the adjacency goes down. So it's clearly bouncing up and down. So let's do some, and again, the log messages here are giving us a lot of information right out of the gate about what may or may not be the problem. And you can see it's both for IPv6 and for IPv4. So it could be, let's see here, show keychain. I'll bet you. All right. So this is reminding me of the issue that, and I'm drawing a complete blank on names right now. I apologize. There was an issue in the back of the classroom with Robert. That's Robert and Dabrian had this issue. I was trying to remember who had the issue. Robert and Dabrian had the issue with the keychain values, and these were the messages that they were receiving when the keychain was invalid, that at least the accept lifetime was off, right? And something to be very wary of here when you're checking these keychains. Excuse me. When you're checking these keychains, is to watch for a space character in between the last character and the double quotes. So if it was like this, C1SC0, and then the quotes were here and there was like a space there, that space counts in terms of the text that's being used for the key, right? Okay, so everything looks good there. How do we get to the branch? Let's take a look at the branch. And so again, this message is definitely telling us that something is not right. So branch is 10.2.10.1. So if I was to say show IP, because again, this is being reported as an IPv6 issue. So show IPv6 EIGRP interface. So the sub-interfaces are good, right? 210.100 and Ethernet 0.1. And if we go to the job aids, I'll bet you that that is Ethernet 0.1. Let's see. Yep. So it's the link between HQ1 and HQ2. So this is not showing as an EIGRP interface. And again, when we look at the log messages that we're getting, what interface is indicated in here? Ethernet 0.2. So there's definitely something wrong with the EIGRP. So let's do this. SSH -L admin to 10.1.2.10. And let me pull this up again. I can never remember these IPs. 10.1.2.10. Okay, so we should be good to go here. And hopefully we're going to get connectivity. Okay, excellent. So CISC 0. All right, so server. That is not where I wanted to go. So is it possible, and am I missing show IP interface brief? So it's Ethernet 0.2. How about a show run interface Ethernet 0.2? So we're 10.255.0.1 and the IP, and this may be a case of, did I look at the wrong IP or I went the branch router? Yeah, I jumped on the wrong IP. No. Yeah, that was right. Oh, 10.2.10.1. So I typed in the wrong IP. That's a more likely scenario. Okay, so SSH -L admin 10.2.10.1. And let's double check that just to make sure. And I'm actually going to write this down. So the branch is 10.2.10.1. All right, so let's go back to the command line here. And again, pretty substantial lag, but we should see, and yeah, there's EIGRP authentication is on this interface, and it's using the keychain that we were just looking at. So it's doing IPv4 and IPv6. Yeah, it's got to be the keychain. And the reason I say it's got to be something with the keychain, or something with the authentication, is that both IPv4 and IPv6 are using the same keychain here on this interface. And the messages we're getting are for both IPv6 and IPv4. So this has got to have something to do with that. And why 10.2.10.1? All right, let's see if we can get over there. And hopefully this is not going to be an issue, because that is the only connection we have right here over to the branch is via the HQ1 router, and it says that the IP is 10.2.10.1. So we may have to go fishing into the documentation that's not correct. And let's give it a second here. Yeah, so this is going to be a problem. Let's do ping 10.255.0.2. What about 0.3? All right, so and this would be very disappointing because these are challenging enough as it is. So if they put the wrong IP in the documentation, 10.255.0.2, and let me write that down, 10.255.0.2, I think that I think that is the IP address for the branch router. So yeah, this was definitely not kind. So we rely on these job aids here, right, in order to access the gear. And of course, they put that caveat in there that the documentation may or may not be correct. So we watched as twice I tried to SSH to, where was it at? Actually, it was a little higher up, over to 10.2.10.1. And that is not the IP. You notice we just got the prompt back at timed out. The correct IP for the branch router, and you're probably wondering, well, where did you come up with this? Right? So again, I simply looked at the IP address on the HQ router, saw that it was a .248, right? And figured that it's got to be, if we're .1 on the HQ router, we could be .2, we could be .3, we could be .4, right? So again, I just started pinging in order going up, up until I get outside of the 248 range, right, or the subnet mask of a .248, which would be 128, 192, 224, 224. What did I say? So 128, 192, 224, 240, 248. So we've got a slash. What is that? 1, 2, 3, 4, 5. So 24, 29. So slash 29, right? So we've got what, 3 bits left? So 6 assignable IPs. So there's 1, 2, 3, 4.5 and .6. Our broadcast would be .7, and the network subnet ID would be .0. So it had to be one of those 6 IP addresses right there on the other side of the connection off of the HQ router. So we got lucky, we pinged .2. That just happens to be the IP address, and again, that was not cool. So we are now on the branch router though, and so now let's go ahead and take a look, and you can see it's definitely bouncing here as well. So show IP interface brief. Only 2 interfaces, right? We've got the LAN facing interface, and then obviously this is the 10.255.02. So it's got to be show keychain. Whoops. And boy, quite a bit of lag again. All right. And yep, this is exactly what we saw in the in-class lab, right? So take a look at the accept lifetime here. So it shows 1,111 seconds, but it doesn't say valid now. So what if I were to say show clock? Yeah, so clearly not valid now because it does have the current time. So let's do this. Let's get into global config. We're going to say keychain KC1 and keychain KC1. Let's do key 1. And this is where we're going to do we're going to say no. Oh, that's annoying. So we're going to say no, except, and actually, let me see if I can cut and paste this. It'll be easier to do. All right, so it listed it out. And where did that listing go? It just showed us the keychain. I'm looking for where it showed it. Do show keychain KC1. It isn't going to allow us to do that. So we're going to say no keychain, or no except lifetime, sorry. We'll say no except lifetime local, and it's 11:11:11, and this is November 11, 2013, and then the duration was only for 1111 seconds. All right, and then we'll just simply say accept lifetime. Whoops. Accept lifetime. We'll do local. And actually, we could just do time to start. So we saw, where's the time at? It thinks it's what, April 26th? So here's what we'll do. I'm going to say 000001, and we'll set the month to be, it thinks it's April, so I'm going to say January. Start on January 1st. Oh, and you know, yeah, the send, okay, then send accept. All right, so January 1st of 2013, and infinite. So it never expires. All right, so now we say do show keychain. Okay, so now the accept time is valid forever, and the send lifetime is valid forever. So we should be good. Let me take a look at show run interface Ethernet. Was it 01? Let's make sure do show run interface Ethernet 01. Let's make sure that, yep, KC1, and boy, oh boy. They, okay, all right, that's right, that's right. Sorry, I was looking at this, I'm like, wow, they got the autonomous system numbers wrong. Do show run section router EIGRP. Do show run section router EIGRP. Okay, so we're good. So the IPv4 was AS100, IPv6 was AS1. No passive interface default. So we should do show IP EIGRP neighbors. Let's see for IPv4. Okay, it looks like we're up, and you'll notice we're no longer getting the errors. So that is good. What about do show IPv6 EIGRP neighbors? And that is a problem. Do show IPv6 EIGRP interfaces. So interface Ethernet 0, 0, and 01. We're good there, and the keychain is good. Did I check this? And I'm going to hate to exit off of this if this is not what it is. Let's say show IPv6 EIGRP interfaces. So I'm checking to see which interfaces. Yes, and that has got to be it. Show run interface Ethernet 02. So the EIGRP process for IPv6, if we did a compare and contrast real quick as a troubleshooting method, everything looks good here, but if we go back and look at the interface here, that command, right, that enables the EIGRP process on the interface is not on this interface, right? And so this is going to resolve this problem. So let's go into interface Ethernet 02 and say IPv6 EIGRP 1. And we should, yeah, wow, that was quick. Okay, great. So the adjacency is up. So we are good to go. And let me, I don't need the job aid for this. I need the scenario. And what was the question? So I cannot ping the IPv6 internet from the branch router. Now that should be resolved. This is a separate issue, I believe, because it works fine through ISP1. So if we had to go back to the branch router, SSH-L admin, to validate this. 10.255, glad I wrote this down. All right, so let's jump back onto the branch router real quick, which again is not at 10.2.10.1. And C1SCO. And now let's try to ping, and I'm glad I wrote this down, 2001:DB8 :0 :delta : 100. All right, fantastic. Okay, so now we're out of the lag here, and we're back to the HQ setup. So, multi-protocol BGP, it works going through ISP1, but not going through ISP2. And again, the question was regarding the configuration of, is it V4 over V4? Is it 6 over 4? Is it 4 over 6? So here we are in HQ1. Let's say show run section router BGP. And I love BGP. So when we take a look at this configuration, sorry, get this back HQ1, there we go. When we take a look at this configuration, right, there's a command that's not here, and it's the no default, or no BGP default, no BGP default IPv4 unicast, right? So that command's not here. So when we look at this, we see we get the address family for IPv4, and we have these two statements here, right? And the reason these two statements are here are not to confuse you, although sometimes they end up doing that. But these two statements are here because we don't have that statement. And again, since this statement right here is typically used on a provider edge router, right? In a provider environment. And no BGP default IPv4 means we have to come in and we have to manually activate everything. When this command is on, you have to manually activate all of the peerings. When that command is not on, when I enter the neighbor statement, it auto-magically adds in, well, actually, I'm pointing at the wrong neighbor statement here. When I add the neighbor statement in for 209.165.206, it auto-magically adds in the activate statement. So it's going to auto-magically activate the peering, right, or the BGP peering for that neighbor. And so we see these two entries here, no neighbor 2001 DB80 Fox : 1, and no neighbor 2001 DB80 11 Baker : 1 activate, because it's making sure that it doesn't activate these IPv6 peerings under the IPv4 address family. So you'll see if you look down here, here they are, right? They're right here. Because again, you've manually got to come in, you manually have to come in here and you have to do this. And so if I was to add this statement right now, and that's what we're going to do right now, I'm going to drop this statement in here, you'll clearly see that this is dual stack, right? This is straight up dual stack. It's V4 over V4 and V6 over V6. There is no 4 over 6. There is no 6 over 4, right? It's 4 over 4 and 6 over 6, dual stack, multi-protocol BGP. And as soon as I drop that command in here, these will go away, because as soon as you put this command in, it mandates that you do the activate statement yourself manually. So let's clear the screen here and let's get control of the cursor. So for HQ1, which is working, we're not having any issues here. Let's come in and go into global config. Let's say router BGP 65000. And we're going to say no BGP default IPv4 unicast, right? And that's the whole command. Now watch what happens. I'm going to enter that command, and when we go back and say, actually we're in the BGP config mode, do show run section router BGP, where did the no neighbor IPv6 address activate statements go here? They're gone, because they're not needed anymore, right? So basically what BGP is doing there is it's ensuring that you don't try to activate the v6 peering under the v4 address family. But now that we've said no BGP default IPv4 unicast, right? So don't default things under the IPv4 address family. Now if I enter something in, so I can even do this, right? So we'll put a bogus neighbor in here. I'm going to say, let's say, well, let's be careful here. I don't want to mess this up too bad. Let's say 209.1.1.1. And we'll say that the remote AS is 1111, right? So now when I hit enter, what do you think? Is it automatically going to drop that in there, the activate statement? So we put that in. I say do show run section router BGP. Here is the neighbor statement. Where is the activate statement? It's not there, right? So again, this is just a little sidebar, but it's definitely needed to clarify why you're seeing the no neighbor IPv6 address statements. Initially we saw them here. My guess is we're going to see them over on router HQ2, right? And by putting in, hey, don't auto-magically activate peerings under the IPv4 address family, now we would have to manually come down here, and I'd have to say, again, neighbor 209.1.1.1 activate, because it's not going to do it by default. So we don't need that. I put that in there as a demonstration, so let's get that out of there. So let's take a look at HQ2, and this should be pretty straightforward. And the problem, let me read this, is IPv6. Cannot ping the IPv6 internet, and multi-protocol BGP seems to only be working through ISP1, while the session with ISP2 is not being fully established. So how do we check to see what peerings we have in a multi-protocol BGP-CISCO? In a multi-protocol BGP configuration, we say show BGP IPv6 unicast, and I could say summary. And what are we looking for? We're looking for the peerings, and more specifically, and again, it kind of wraps around here. It's unfortunate that this wraps like this in the window, but this prefix received, you typically see that down here, and then underneath it, it'll show you, or you're hoping that it shows you an integer, 0 to whatever, which corresponds to the number of prefixes that you have received. So if you see 0 or any other positive integer, you're in business, right? You're receiving prefixes from that BGP peer located at 2001 DB8 0 Fox : 2. And that's a good thing. What you don't want to see is idle, right? Because idle means it's just sitting there. That would mean that we have a problem. So, and this looks like it's going to be pretty straightforward. If I come back over to HQ2 and I run that same command, so let's do a compare and contrast here. Because again, they give us HQ1 as a working solution. So what about a do show BGP IPv6 unicast, unicast, what did I say, summary. Yeah, so what do you see that's different? HQ2 has how many peerings? 1. What about HQ1? Yeah, HQ1 has 2 peerings. So when we look over here, you can see that HQ2, right, only has a single peering. It doesn't have 2 peerings. So one of those peerings is probably the IBGP peering. And when we look at this, you can see what's the AS? 65,000 on HQ2. That's our autonomous system. So this 12 that's received here, let's look at HQ1 again. There's no coincidence that the numbers that you see for the prefixes received here are 7 internal, 5 external, just looking at that autonomous system number, for a grand total of 12, right? And when we look over here at the internal peering on HQ2, it's 12. So the problem is that this is an IBGP peering. So the reason that HQ2 isn't working is that the peering, sorry about that, back to the diagram, the peering here with the ISP is not working. And so again, let's now go in, let's take a look at that configuration on HQ2, and let's say show run section router BGP, and let's get the whole config up here. And so now again, we've already looked at the working solution. We've already looked at the working solution. So let's take a look. All right, so here's an IPv4 peering, IBGP, IBGP again, and I'm saying IBGP because our autonomous system number is 65,000, and so are those. Now here are the ISP peerings. I'm sorry, I think I said IPv4 here, but again, it's IPv4 and IPv6. This goes over to HQ1, and now we get down to the ISP2 peerings. So we've got the neighbor statement here, and lo and behold, what do we have down here under the address family IPv4 unicast? Specific statements saying don't activate these under the IPv4 address family. Because again, we're not doing 6/4, right? So we see here that these are the external peerings. Now we come down to the activate statements, and what do we think is missing here? Exactly. This is my IBGP peer, which would be the fox:2. Where is the activate statement? Where is the activate statement for this DB8011 Charlie 1, who just happens to be ISP2? It's missing, right? So again, this is straight up V4 over V4, V6 over V6, dual stack, right? And the activate command is missing here from the IPv6 address family, because we get the no activate under the IPv4 address family because these are IPv6 addresses, so we need to come down and activate these, right? Unlike an IPv4 edition right now, where by default it's going to put it in there. So again, if I was to come into global config, and let's say router BGP 65,000, if I was to say neighbor, and let's say 2001::10 remote AS 10, right? So what lines are going to get added to the config? We're going to have a neighbor line added in this section because I'm typing it in right now. We're going to get a no neighbor activate statement here under the address family for IPv4 because this is an IPv6 address. But is it going to put an activate statement in there for us? And let's do show run section router BGP. No. Because again, this is an IPv6 statement. So here we go. We get, where is that? 2001:10. So here it is. So that's what we typed in. It's not for the address family IPv4, so we get the no neighbor activate, right? Because it's an IPv6 address. BGP is smart enough to see that I probably, that if I wanted to put this under the address family for IPv4, I'm going to have to come in here and I'm going to have to make this activation, right? And then we get nothing down here. So what I would need to do is go into the address family for IPv6 and make that change. But I'm simply going to pull this statement out because, again, putting the statement in there to show that with IPv6, you need to manually do the activation. V4 will automatically do it for us right now. But we're going to say no BGP, default, IPv4, unicast, right? And not that that changes anything with the IPv6 setup. We still have to go in and say activate, but now it does clean the configuration up a bit because now when you see this no neighbor, which we should not see anymore, right? Under the address family for IPv4, it is gone. So what's our fix? Our fix is to get into the address family for IPv6 and to say neighbor, And IPv6 addresses 2001:0:11Charlie::1 activate. And we should see a peering message pop up here, although BGP is a little slower than EIGRP. And there we go. And if we wanted to fully test this, all we would have to do is shut down the interface. Well, actually, there's sub-interfaces there. But yeah, if we shut the parent interface down here on HQ1, do show IP interface brief. Let's see if that does what we need it to do. So let's get an interface Ethernet 00 and let's say shut. So now from PC1, so we're back on PC1 here, and let's go ahead and try our IPv6 address of 2001:0:0:Delta::100, and that worked. And now let's trace that out right now as well. Let's make sure that we're going outbound via HQ2. So we should see that FF, or was it FF:2 or F:2? Seemed like the IP addresses ended in 2 over on HQ2 side, and they ended in 1 on the HQ1 side. But hopefully this has cleared up the issue of whether or not it was V6 over V4, V4 over V6. Why did it have that statement in there saying no activate? And again, hopefully it's cleared that up, and it's basically just, again, it's a straight up dual stack, and that appears to be going through. And we maybe have to wait for the peering to drop out. What is the interface to the provider on HQ1? What was that? Do show IP interface brief. Serial 10. Do show. That's right, it was a serial interface. So interface serial 10, and we're going to shut that down too. All right, there we go. And now let's try this trace again. We should be going through router 2. Or HQ2, sorry. All right, so here we go. And we're giving traceroute a second here to sort things out. So the first hop is the same to the ::3. Yeah, and it likes that Charlie 1, and then it died out there. And I'm wondering if we're just waiting for, okay, and I wonder if we're waiting for BGP 10. So let me check something real quick here. Let's say do show IPv6 interface brief. And oh, I had it backwards. I apologize. HQ1, all the IPs ended in 2. Is that right? And HQ2 ended in what? Show IPv6 interface brief. So I think we, yeah, I think we had it. Well, most of these ended in 3. That was the sub-interfaces. And then the interface out to the provider, 11 Charlie ::2. Is that what we saw? 11 Charlie ::1. So we would have gone out. Yeah, so we did go out. 11 Charlie ::. Yeah, so we did actually go out the right interface. Ethernet 00. Let me double check this real quick in the job aids. So yeah, I just want to make sure that we're good here. So Ethernet 00. So yeah, we came here, and then Ethernet 02 would have led us out to the ISP, which is that 11 Charlie ::2. And then we've got the other side's 11 Charlie ::1. All right, so we did get out. Again, that was misleading. I thought it was 1 for HQ1 and 2 for HQ2. But everything is working. All right, well, that wraps up Challenge Activity 18. And this was a monster challenge activity, from the stolen switch to the messed up VLAN configuration, the EIGRP component, where it was the same as the lab we had in class, where the accept lifetime was off, and then the BGP configuration for the address family IPv6 missing the neighbor activate statement. All right, guys, thanks for watching, and I will see you on Thursday night.